Hello, Algebra 2A, and welcome to Lesson 44, where we are going to talk about rationalizing denominators. Before we get started, we're going to look a little bit back at how radicals work. And we're going to do that with examples 3 and 4 right here. So when we're dealing with radicals, we can multiply two radicals together if they have the exact same index. So here we have a square root of 3, a square root of 2. We can multiply those together, and then as always, we can multiply numbers together. So this would end up being 8 root 6, because 2 times 4 gives me 8, and then root of 3 times root of 2 gives me 6. On to problem 2, we'd have 4 times there's no other number, and then square root of 5 times square root of 5 is the square root of 25. But something unique happens here. If we multiply square root of 5 times square root of 5, we get square root of 25, which is just 5, because that now is a perfect square. And then 4 times 5 is 20. So that gives us a new property that we can use anytime you multiply a square root of a number times a square root of the exact same number. That's just going to equal the number, which is called your radicand, that number that's underneath there. So square root of x times the square root of x is always going to equal x, and that's what we can use to rationalize the denominator. Rationalizing a denominator is when we write an equivalent expression so that there are no radicals in any denominator. And to do that, if we had, for example, 2 over the root of 3, we can use that property that we just talked about above. I can multiply any radical by exactly itself, and that's going to change it back to 3, which is now a rational number. Now, one thing is when we have fractions, if we multiply our denominator by the root of 3, we also have to multiply our numerator by the root of 3. So we end up getting 2 root 3 all over 3, because the square root of 3 times the square root of 3 would be square root of 9, which is 3. And we would check to see, is there anything that we can simplify, and 2/3, nothing we can do. So that would be our final simplified result. Let's take a look at example 1. So I look in my denominator, I've got that square root 7. So I'm going to have to rationalize that by multiplying by the square root of 7. In my numerator, I multiply by the square root of 7. So up in my numerator, I'd have 4 root 7 all over 3 times root of 7 times root of 7 is 3 times 7. Because remember, when you multiply the root of 7 times the root of 7, that equals 7. Continuing, we'll go 4 root 7 all over 21. And you check 4 and 21. Do they simplify? No. So that's going to be our final result. Heading down to part B. We've got 1 over the root of 12. So I look at my denominator, and I do have a root of 12. Now, root of 12 is not a perfect square, but because 12 is a smaller number, I can see that there is a perfect square in there, which I am going to simplify the root of 12 first. That would be the root of 4 times the root of 3, because 4 is a perfect square. So I'm going to end up now with 1 over 2 root 3. And now I'm ready to rationalize. So if I see a perfect square, I'm going to simplify that down so I have smaller numbers to deal with. So then I'm not multiplying really big numbers and then having to do a lot of cleaning up at the end. So square root of 12 becomes 2 root 3. Then I can multiply my denominator by the root of 3, and I'll multiply my numerator by the root of 3, which is going to give me the root of 3 over 2 times 3, because remember, anytime we multiply root of 3 times root of 3, that's going to be 3. And all in all, we'd get the root of 3 over 6. So who knew, when you have 1 over the square root of 12, that is equivalent to the root of 3 over 6. We're going to take a quick peek at an example of a delta math problem, and then you'll be set to go. So taking a peek at an example problem, we have here 2 over the root of 54. So here we have the root of 54, which we need to realize that the root of 54 is the result of the root of 9 times 6. And the reason I'm using 9 and 6 is because 9 then is a perfect square. And then the square root of 9 can come out as 3. So now we have 2 over 3 root 6. So now I'm ready to go. I have a root of 6 that I can rationalize. I take root of 6, and that's going to leave me with 2 root 6 over, and then this is going to be 6, remember, because root of 6 times root of 6 is 6 over 18. Now here we have our first time where if I have a 2 and an 18, those are both divisible by 2, so here I'd have the root of 6 over 9, and there would be our final result. So you will practice today, day 1, looking at monomial denominators. Tomorrow we'll look at binomial denominators. So you're ready to go. Thanks for joining, and we'll see you next time.